Hi everybody! Today we're going to take a look at parallelograms. As you already know, a parallelogram is a quadrilateral with both pairs of opposite sides are parallel. So if a quadrilateral is a parallelogram, then the opposite sides are congruent, meaning they have the same length. And its opposite angles are congruent. They have the same angle measurement. Consecutive angles, or angles next to each other, are supplementary, meaning they add up to 180 degrees, and the diagonals bisect each other, meaning they cut each other into two congruent pieces, or cut each other in half. So using this information, we can solve a variety of problems about parallelograms. The first example listed here in your notes asks you to find the value of x and y. Well, x is located here on the top of this figure. Looking at this figure, it is a quadrilateral. It has four sides, and opposite sides are parallel. That's what these triangles indicate. Therefore, these arrows showing its parallelogram show that this side, x plus 4, is congruent to the side that is labeled 12 because they are opposite sides. So I can use the equation x plus 4 equals 12 to solve and find out that x has to equal 8. Just like opposite sides are congruent in a parallelogram, opposite angles are congruent in a parallelogram. That means that this angle here that's labeled y and the angle opposite it on the other side labeled 65 are equal, so y equals 65. I can also use the diagonals in a parallelogram to find other information. So looking at this figure, JKLM, the question tells me it is a parallelogram. That gives me a lot of information. So to find these indicated measures, I can use this parallelogram to solve it. A asks me to find NM. Well, N goes from the center to M. I can also see that it's a piece of the diagonal KM. Well, I know that in a parallelogram, the diagonals are cut in half by the other diagonals. So if Kn is 2, then Nm is also 2. If Kn is 2 and Nm is 2, based on the segment addition postulate we learned way back at the beginning of the year, Kn plus Nm is the same as Km, so Km must equal 4. We can also look at the angles in the parallelogram. Angle JML is this angle down here at M. It is the entire angle at M, not one piece of it. J to M to L gives me that entire angle. Well, I know that consecutive angles in a parallelogram, J to M, are supplementary. Supplementary means that they need to add up to 180 degrees. So if J is 110 degrees and M has to get me to 180, then JML must equal 70 degrees. Now they're asking for KML, or the little piece of the angle here. So for KML, I'm looking for just that little piece. Well, if I know that JML, or the whole angle, is 70, and I know that this little piece is 30, the rest of that angle must equal 40. Now, using what you know about parallelograms, what we've gone over, and using the examples we've just done, you should go ahead and try examples 3 and 4 on your own. Pause the video, take a moment, figure them out, and when you're finished, join us back and we will go on to the next page. Now that you've looked at how to use a parallelogram to solve for pieces, well, what if I have a quadrilateral and I want to know, is it a parallelogram? Well, I can prove that a quadrilateral is a parallelogram if both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, one pair of opposite sides are both congruent and parallel, or if the diagonals bisect each other. Now, when using these, you have to use the entire statement. So it must be both pairs of opposite sides are congruent. If you only have one set of congruent sides, that will not prove the quadrilateral is a parallelogram. So let's look down here. In quadrilateral WXYZ, the measure of angle W is 42, X is 138, Y is 42. We need to find the measure of angle Z and then determine if WXYZ is a parallelogram. I recommend that we start by drawing a picture. I'm going to draw a quadrilateral and I'm going to label the angles in order as they are named. So W, X, Y, and then Z. I'm also going to go ahead and fill in my angle measurements based on what they tell me in the problem. Now looking at this, I would like to be able to just say, of course it's a parallelogram, but I need two sets of opposite angles to be equal. And I cannot just assume that this angle is 138 until I do the math. Well, we know that the interior angles of a quadrilateral add up to 360 degrees. So let's see what the interior angles that we already have add up to. So the angles I have add up to 222 degrees. Well, taking 360 degrees and subtracting those 220, I'm left with 138. That means that the third angle here is 138 degrees, which means that I now have two pairs of opposite angles congruent. So therefore, WXYZ is a parallelogram. Now, looking at example number 2. For what value of x is quadrilateral CDEF a parallelogram? Well, when I look at the diagonals in a parallelogram, both diagonals need to bisect each other or cut each other in half. I can see that CE is already cut into congruent pieces, as that's what these little tick marks indicate. But in order for FD to be cut in half, FX minus 8 must equal 3x. So, 5x minus 8 equals 3x. I can subtract 3x from both sides, add 8 to both sides, divide by 2, and it must be for the value of 4 that would make this quadrilateral a parallelogram. Now, using what we've done in the past two examples and what we've talked about parallelograms, go ahead and determine what reasoning you can use to show that these are parallelograms. Look at each picture in 3, 4, and 5 and determine whether they are parallelograms. In class, we'll take a look at these examples and continue practicing.